Well, if f is a map from A to B, then f of A is contained in B. That's pretty much all we know. And we also know, since C is a subset of A and D is a subset of B, we know f of C is also contained in B. And we know that f inverse of D is contained in A. That's pretty much all we know. But let's go through some of the statements one by one and see if we can rule them out or confirm them. So C is a subset of f inverse of f of C. That's true, actually. Is the answer just going to be A? Right? If I have an element of C, and I take, and I, certainly if, so what is this set? This is the set of things in the codomain B. This is the set of things in the codomain B, which are mapped to by some element of C. Now there could be things in that set which are mapped to by elements outside of C, if the function is not injective. But certainly, if x is an element of C, then yes, it gets mapped to something that the set C gets mapped to. So pretty sure that's the answer. What I'm going to do is go through the other options and try and give reasons why they are not true. Yeah, so this is kind of not true for a similar reason. This is the set of elements in the domain which get mapped into D. But there may be things Wait a minute. I'm going to have to draw some pictures here. So here's A, here's B, here's C, and here's D. So f of C, in fact, let me draw these with different colors. There's C, there's f of C, there's D. Now f inverse D can be complicated. I'm not going to write f inverse D just yet. So if I have something in C, oh, this one's wrong. Yeah, this one's wrong. Ugh. Oops. If I have something in C, it gets mapped into this set, but when I pull that back, it's possible it could be somewhere else. My bad. Well, I'm happy I went through the other options because this one is correct. If I have something, let's call this set, let's say that's D. So that's D. When I take f inverse D, I get something like this. Yeah, aren't these in fact the same? F inverse of D. These are, I think these are in fact equal. I'm becoming so unsure of myself that I want to go through them all. Yeah, so this is going to be, I don't think this is true either. Take something in C, and map it here. But now when I pull this back, I could get something outside of the original set C. But then why is this one not true? Oh my gosh. Why am I struggling with this? C, map C here, pull it back, we might end up outside. So this I'm having a hard time debating which of these is false. I don't know what's going on in my brain right now. So this is definitely not true. There's no relationship between the sets C and D. Non-empty subsets of R doesn't say F is continuous or anything like that. So it doesn't matter that we're a subset of R. This is certainly false because they don't even exist as the subsets of the same thing. I think f of f inverse of D is equal to D. How do I show this is false? I need something in C, which is not in this set. Oh, of course. course, yes, there may be elements in D that do not have, that never get mapped to by anything in A. That's why. Whew. Okay. Yeah, if there's a subset of B, like let's call that the set D, but let's say that there's nothing in A that maps in there, then that's the empty set. Right. Okay. Yeah, this took far too long. It's unfortunate that my first instinct was correct on this one, and then I second guessed myself. Anyway, that's I mean, it's a nice problem. It really does test your understanding of this inverse function notation on sets. But yeah, this silly little, this exception that I thought of is, I think that's probably the only case where this can break. If D is a subset of the range of F, then this would be true. All right. If I still have a mistake, I'll let you know. Thanks for watching.